This video is about the 5 biggest mistakes that math students make. Number 1 might kill you. Okay, that was a little dramatic. Today's joke of the day: how is a light beam not like a tomato? Stick around till the end to get the answer. Check this out. Homegrown tomatoes. Looks like a green pumpkin. Numero 5, the biggest time waster in the world, not showing work. The only reason that students skip work is to save time, but my experiments in my own classroom show that not showing work actually wastes more time. It slows you down. And then on top of that, this happens. You get an answer completely correct, except that when you check it, it's totally wrong. So where's the error? I've done an experiment with students that I've worked with one-on-one, and I asked them, 40% of them are like, I don't know. The other 60% find an error. What's wrong with that? In all the students that I've taught, only 2 have ever noticed that there are actually 2 errors in this work. Now, look how easy this is. We just show work. Inverse operation again, answer. And as a bonus, it's faster. So showing work is a win-win situation. Numero 4. Using your eraser as a mathematical operation. The eraser is a problem deleter, not a problem solver. But a lot of times when students do math problems, parts start to disappear like the nerds from a fight in the hallway. That's what you're supposed to do. Hashtag nerd is a compliment. You might have heard the expression use it or lose it, but for us, number 4 is use it or keep it. Let's do this example. -7 equals 2x plus 8. Your temptation might be to add 8 to both sides. And although your teacher might mark it wrong, you might get y and then just add 8 again next time you do this problem. Instead, let's look at it with the rule, use it or keep it. 8 plus 8 doesn't cancel. We use it. 8 plus 8 is actually 16, but that doesn't simplify the equation. Instead, we subtract. 8 minus 8, we use it. That cancels, and we're left with -15 equals 2x. And here's a second source of errors. Super common. Students try to cancel a ×2 with a ×2, but if they use the rule, use it or keep it, they use it. ×2 times 2 is ×4, which doesn't simplify. So instead, they go back and say, hey, I should actually be dividing by 2. And then we get a third source of errors. That negative sign magically disappears. Usually because they confuse us. However, we get positive 15 over 2 instead of getting the negative 15 over 2 that we should get. Numero 3. Not doing the distributive property correctly. This is the biggest mistake that all students make at some point in their lives. Now, why isn't this number 1? Here are 4 distributive property problems in increasing order of difficulty. You know the drill, try them on your own. Here's what happens with the first one. Students frequently draw the arrows to do the distributive property, then they get the answer, -2x plus 3. What happened here? There's 2 things that could have happened. The first is they multiplied the -x by 2, but they forgot to multiply the 3 by 2. The second one is that they just never multiply the 3 by the 2. The answer to this one, -2x plus 6. Let's go to the next problem. It's the very next level of difficulty. Students who can do the previous problem successfully will still have trouble with this problem because they know that the 3 has to get distributed to the 2x and to the -4, but then they get 6x plus 12. And that happens because the student either thinks that the distributive property should always have a plus or ignores the fact that the 4 is negative, breaking the use it or keep it rule. The actual answer is 6x minus 12. Click like if you got both of those right, and please ask questions if you have any. I will answer your questions. This next problem, even if students are able to do the previous 2, students still have trouble with this problem. The problem with this one tends to be when the negative sign is outside, things get jumbled up in the student's head. On top of that, the quantity of negative signs floating around gets overwhelming, so that students end up getting almost always, if they get it wrong to begin with, they almost always end up getting -15x minus 10. In fact, -5 times -2 is +10, so the answer is -15x plus 10. And finally comes this one. Students get the first problem, they get the second one, they get the third one, and then they get to this question, they get it wrong. What happened? They see the negative sign and they don't know how to distribute it. And so they make the parentheses disappear and they get negative 3x minus 4. But that violates the rule of use it or keep it because all they did was erase parentheses. If we recognize the negative sign as a multiplication by negative 1, then that gives us something to distribute. And we get negative 3x plus 4. Número 2. Hashtag nerd es un piropo. Doing the wrong operation. Now, if you think this step doesn't apply to you, then congratulations. You've never gotten a math problem wrong. Yay! Every mistake that we talked about so far involves making the wrong choice for the initial operation. Pay attention to this problem because this problem actually talks about what happens when you do make the right choice and still get the question wrong. Click like if you caught all the mistakes. Did you notice that at the end, the student correctly chose to divide by 3, but then got the wrong answer? Negative 21 divided by 3 is not 18. That's the first error. Right above that, the student correctly chose to add 4, but then incorrectly said negative 17 plus 4 is negative 21. It's not, it's negative 13. Right above that, the student correctly chose to subtract 2x. That's one of the many options to perform here. But then the student got negative x minus 2x is positive 3x. It's not, it's negative 3x. And then right above that, they distributed the negative sign, but then got negative x minus 4 instead of negative x plus 4. 4 mistakes. So can we go and just change all the numbers? Nope. Unfortunately, when errors compound on top of other errors, we can't just go back and change the numbers. So let's do this problem correcting the errors that the student made. First, we distribute the negative 1, and we get negative x plus 4 equals 2x minus 17. Then we subtract 2x like the student chose, but then we get negative x minus 2x is negative 3x. Then we cancel the plus 4 that appears now. It's not a minus 4 anymore, it's a plus 4. We cancel the plus 4 by subtracting 4. Negative 17 minus 4 is negative 21. You might notice that the left side and the right side have a negative 21 here. That's absolute coincidence. Any other situation would have had two totally different numbers here. We divide by negative 3 to cancel the multiplication by negative 3, and we get x equals 7. Número uno, finally! Not answers you're checking. I did an experiment with my class where half the class was required to check their answers and half the class was required to not check their answers. Which one do you think did better? Obviously, the half of the class that did check their answers. So why don't students check their answers? They want to save time. But does this mean that you should be checking all your answers in every problem on the ACT? No drawings right now because I want you to pay attention to this. On the ACT, time is a factor. You don't have time to check every single answer. It's not possible. What you need to do is run through the entire section of the ACT, circling all the answers that you think might have a problem. And then when you're done with the entire thing, then go back and check your answers. So if I'm saying you should only check your answers for the ACT at the end, then what am I really saying? The purpose of this experiment was really to convince the class that checking your answers is better. As time went on, the students that decided to continue to check their answers for homeworks, tests in class, assignments, group work, those are the students that improved the most. They learned the material better. They got better. If you don't check your answers on everything except for those long tests, you're losing points and you'll never figure out why. You have to check your answers. But it's not like a simple careless error is ever going to make a bridge collapse, killing 114 people and injuring another 216. Oh. Getting hot in here? Oh. Or like not being able to handle big numbers is going to cause a giant rocket to explode, losing 4 satellites and costing $500 million. Okay, but we'd never send a telescope out into space only to find out we have to send astronauts out there at a cost of $1.5 billion to fix a 2 micrometer error in mirror construction. Well, at least she looks great in glasses. Hey Hubble, want to hear the joke of the day? Oh, I get what we're doing. We're anthropomorphizing Hubble's reaction by posting pictures that Hubble took over the years. This joke is brought to you by Heinz. It's not. How is a tomato not like a light beam? With a light beam, you can never catch up. Guys, thanks for watching. Watch one of the videos on the left. Don't forget to subscribe. And thanks, Hubble, for an amazing couple of decades. Is that the real Eye of Sauron?